So welcome everyone. First, can you hear? Yes. So glad you could come to hear Vulnerabilities and Resilience of Electrical Grids in Wartime Lessons from Ukraine with Volodymyr Kudrytskyi and Mariana Bujerin. I'm Elizabeth Wood, and I'm the faculty director of the MIT Ukraine program, as well as a professor of history and a member of the Center for International Studies. And it's my great pleasure to introduce Mariana, who will then introduce our speaker and take the whole event away. So this is a wonderful Venn diagram of people from the energy field, the MIT Energy Initiative, from the Center for International Studies, from the Security Studies program, and from the Ukrainian community. We have 4 co-sponsors for the event: MITI, Security Studies program, the Center for International Studies, and the MIT Ukraine program. So it's really exciting to have a very diverse audience with many interests and many questions. When our speakers have finished, I hope you will ask questions. Our friend Maria Montague will have this mic, and she will come around, and Mariana will recognize you if you want to ask a question. We also have welcome to our viewers online. We have some number of viewers on the webinar as well. I want to quickly also announce that there are some handouts outside the door from the Security Studies and Center for International Studies about upcoming programs. Next week, we will, on Monday, 17th, we will have Alicia Chen, who is the Elizabeth Newfer Fellow and journalist, speaking about contextualizing Ukraine today, Taiwan tomorrow. As you can imagine, the Ukrainian and Taiwanese issues are very linked in many ways. So if you pick that up, it's from 12 to 1 next Monday at the Center for International Studies. That one's only in person. Without further ado, let me introduce our very good friend Mariana Bujerin, who has been a wonderful member of the MIT Ukraine program community. She's senior research associate with the project on managing the atom at the Belfer Center at the Kennedy School, at that other school up the road, or up the river, Harvard. And most importantly, in addition to being at Harvard, she's the author of Inheriting the Bomb, The Collapse of the USSR and the Nuclear Disarmament of Ukraine, which is an award-winning book, and I highly recommend it, on why Ukraine chose, under duress and under a variety of circumstances, to give up the bomb in 1994. That book was the winner of the 2024 William E. Colby Military Writers Award, the first female writer to receive that in the 25 years of the award. She's worked as a Stanton Nuclear Security Fellow with MTA and an international security program at Belfer. She's also been a visiting professor at Tufts. She's been at the Davis Center for Russian Studies at Harvard, and she's been in Frankfurt. She's worked on international non-proliferation, arms control, nuclear crises, and post-Soviet nuclear history. So let me hand it over to Mariana, and we'll start the event.
So much for your kind introduction, Elizabeth. I'll stand up so I can see you. I can see you better, and I'll promise I'll sit down in a bit. And yeah, you know, Elizabeth, nobody's perfect. Somebody has to work at Harvard too. So, you know, I wish I could. But thank you all so much for joining us this afternoon, and those of you who are joining us online, to hear from a very special speaker who made it here all the way from Ukraine. It's no easy task to travel from Ukraine today. And a person no less than someone who was at the epicenter of managing and safeguarding Ukrainian electrical grid in the middle of the war. Now, as you can all imagine, it's an unprecedented set of events for any grid operator to try to safeguard and manage the grid in the middle of concerted missile strikes against critical infrastructure. And so we are very fortunate to hear firsthand about both the what has been learned about the vulnerabilities of electrical grids in armed conflict, but also where are the sources of resilience, what has been learned, and what all of the other countries, including this one, could glean from these lessons from Ukraine. So it is my distinct pleasure to welcome and introduce Mr. Volodymyr Kudrytskyi, who served as a CEO and chairman of the management board of Ukrenergo, which is Ukraine's grid operator, so the operator of transmission system, from February 2020, so right smack in the middle of COVID, right, to September 2024. So basically the first 2.5 years of the Russian invasion. So under Mr. Kudrytskyi's leadership, the Ukrainian grid was prepared to be disconnected from the Russia-Belarus managed grid, connected grid, and connected to the European network of grid operators, which is no easy task in and of itself, but Ukrenergo, under Mr. Kudrytskyi's leadership, managed to do that in the beginning of the war, and he would be, certainly the person to tell the full story about that. Without further ado, let me turn the floor to Mr. Kudrytskyi, and please join me in just welcoming him.
Thank you. Thank you very much. Well, it's a great pleasure to be here today, and thank you very much for the invitation and for this perfect organization of our today's meeting. I indeed had a pleasure to operate or to manage the company in the most relaxed period of its existence, like COVID and full-scale invasion. Of course, when COVID started, we thought that we had a problem at the time, but of course, it was absolutely different from the challenges we faced when full-scale invasion started. Originally, I joined the company for one single purpose. We had a dream of disconnecting Ukrainian power grid, which was traditionally, historically connected to Russia and Belarus, the former Soviet grid, and connected to the continental grid of Western Europe. Even in 2017, when we started this process, and when nobody believed that it would be possible, because synchronization of big electrical systems is something by complexity close to transplantation of human organs or something like that. So you need to be internally ready for that, and you need to be internally compatible. Even then, we already realized, because war was ongoing since 2014, and we were realizing at the time that it was a security issue for us. We could not stay longer within the direct control of our power system by Russia. But it was a process. It took us like 5 years to prepare ourselves for this exercise. And in autumn 2021, when Russian troops were already in the border, for several months, they were doing this constant training together with Belarusian army. We had to pick up a date when we would disconnect from Russia, operate for 3 days in so-called isolated mode, so without any external support from the big external power systems, and then connect back to Russian grid. And then in 1 year after that, we meant to be connected to European network. We had to agree this date of disconnection, of this temporary disconnection with Russia, and they picked up a date. We proposed like 6th or 7th of February 2022, and they proposed 24th of February 2022. Their grid operator, which is called Rosseti, or Russian network, if we translate it into English, they picked up the date. Their dispatchers that did not talk to our dispatchers for many years since 2014, they called like 5 or 6 days before the full-scale invasion. They called to one of the shifts that was managing the Ukrainian power grid at the time, and they said, "Do you guys really want to do this?" There were many voices in Europe, but also in the United States, warning us that the risk that we would disconnect from Russia, and Russia would not let us in 3 days. Everybody considered this as a biggest risk, so that we would be operating in an island mode, not for 3 days, but maybe for 3 weeks or 3 months. And we thought that it was the worst scenario at the time. However, we still we found a ways to persuade politicians here in the United States, but also in Europe, to let us do this test. And 1:32 a.m., 24th of February 2022, we disconnected last line that was between Ukraine and Russia. It was line connecting Ukraine and Kursk nuclear power plant. And we started operating in isolated mode. I was in the control room at the time. I witnessed this, how the system was balanced. It was well balanced, by the way. And 3 a.m. I went to get some sleep because I was already 26 hours without any sleep. And in 1 hour, I started hearing missile attacks. So full-scale invasion started. I went to the office, and it was what first tough decision to make, because we had to do the test. The test was not just disconnect from Russia. The test was disconnect from Russia and perform certain program, which meant that we had to shut down certain power units and look how the system would compensate for this outage of certain controlled outage of generation. And I called my chief dispatcher and I said, look, we need to do the test. And he said, like, we lost 30% of the consumption in the country. I do not understand which parts of the grid I still control, and we cannot do this. So I said to him, look, it's only way forward for us. We can only be connected to Europe now. We cannot go back, meaning that we need to do the test, because without the test, Europe would not let us in. And he said he would think about it, and in 2 hours he came to me and said, like, we did all the tests, and the test went perfectly well. So we operated for 3 weeks in an isolated mode. During these 3 weeks, there were multiple outages of Chernobyl nuclear power plant, but also there was a seizure of Zaporizhzhia nuclear, which was operational at the time. And I remember the night when I got a call from Prime Minister, like 2 a.m. probably, and he said to me that Russians were attacking unit number, I think 1 or 2 from the tank. And I thought that I was like delusional, or I was dreaming still. And then I just realized it was true. And the problem for us was that we had to disconnect very quickly 2 big nuclear units from the grid that represented probably 15 to 20% of the load at that particular moment. And we had to do it in isolated mode without risking the stability of the system, risking the blackout situation in the country, but we did it successfully. Of course, the personnel of the station, they faced much bigger risks and much bigger challenges in Energodar. And then Ukraine was able to deoccupy some territories in Kyiv, in Sumy, in other regions in the north of Ukraine. There were a couple of successful counteroffensive operations. And since September 2022, Russians started campaign of attacking electrical grid, ultra-high voltage substations, and biggest power plants on a systemic basis, trying to shut us down forever. And they just announced it in their media, in the state media, that they would bring us to the 18th century. So they would shut down all the systems that are major benefits of modern civilization. So I wanted to show some presentation to you about the consequences of these attacks. I was asked before this lecture if that was really that bad. We lost half of our generation fleet in only 4 to 5 months through October 22 to February 23. And we are operating 80 high voltage transmission substations on the controlled territory of Ukraine. And there was none of them that weren't damaged by kamikaze drones or missiles. And Russians, obviously, they targeted primarily auto-transformers, those most important items of the equipment at substation that transform voltage from transmission to distribution level. And basically, these are sources of power for all the residences, population, hospitals, industries, whatever is consuming power in the energy grid. Of 200 auto-transformers that were built in Ukrainian system from 1950s to the present day, in 2 years we had to replace 185. So basically the whole transformer park we had to change during these 3 years of attacks. And these are objects that were hit. Some of them were hit by 20, 30 missiles each. And the blue dots are power plants and red dots are Ukrenergo substations, the transmission substations. So Russians, their tactics evolved. Their primary goal was to initiate full national blackout during winter time. That would cause freezing of water in the pipes in water supply and heating systems. And if we even restored the electricity supply in the country, we would not be able to restore water and heating supply during winter. So the plan was to initiate like humanitarian catastrophe and to destroy the civilian operations which supported frontline. So imagine full national blackout during winter time. You do not have electricity supply, but also you don't have mobile connection, internet, transportation systems do not work, heating systems, water supply systems do not work. Nothing works. It's indeed 18th century. You cannot just refill gasoline in your car because gas stations do not work because they also use electric power to operate. So basically the plan was to initiate this full national blackout for a long period of time, lengthy enough for this water supply and heating systems to freeze, and then probably we would lose the war. So this is example of this hybrid war strategy that you might have heard of, this new concept of big war. It's not about Stalingrad type of battles anymore. It's about destroying vital systems of your enemy. And they launched more than 2,000 missiles, of which 331 missiles actually hit the energy objects, and kamikaze drones. Currently, they are sending 5,000 to 6,000 kamikaze drones at 100 main objects in our power system a month. So 6,000 kamikaze drones per 100 objects a month. First attempt to initiate blackout in Ukraine was on 15th of November. What they tried to do is that they knew that Ukraine had generation of power in the west and consumption in the east. So they basically wanted to attack substations that evacuate power from those nuclear power plants that represented 50 to 60% of the generation portfolio in Ukraine, and create big surplus in the west, big deficit in the east, and therefore frequency would go up in the west, frequency would go down in the east, and the system would be completely shut down. And also they tried to disconnect us from Europe because they knew that we could restart the system quite quickly using emergency power supplies from European countries. And they were partially successful on November 15th. They managed to cut us from Europe, and they managed to split the system into two parts, West and East, but it did not lead at the time to full national blackout. And this is what happened in the West. So some Western regions, which are marked in dark blue, they were actually in blackout. It was not full national blackout, but the most Western, so to say, part of Ukraine was still connected to Europe. It disconnected from Ukrainian grid and was still connected to Europe, so it survived. And then full national blackout was happened only once to us. It was 23rd of November 2022. It was almost complete shutdown of the system, apart from some Western territory that survived because it was still connected to European grid. Actually, Russians cut us off from European grid and split the system into three parts. Two nuclear power plants in the northwest, like an island, western part, and eastern part. And all those parts, because they were not balanced, they collapsed in a matter of several minutes because of cascading frequency effect. We managed that. I remember that day. It was, I think, it was a celebration of Thanksgiving in U.S. Embassy in Kyiv at that time. I was there for 30 minutes maybe after I realized that we could restart the system from zero, and we powered up our nuclear power plants. Because when you lose your nuclear power plants, the most important thing is to supply power as quickly as possible. Then you can restart reactors quite soon. If you don't do this, you will spend like 1 or 2 weeks before you can restart. And because nuclear power plants are 55% of Ukrainian generation, it was extremely important to us to make sure that power plants are supplied with power so we can restart them quickly. And it was a celebration. I remember that very vividly. It was a celebration of Thanksgiving. I think in U.S. Embassy, they used candles at the time. But everyone was relaxed because I already brought them this good news that in few hours we would restore the system, and it happened so. We started the system by injecting power from Europe and from hydropower plants that have this black start capability, if you know what I mean. It's capability of the electric elements of electric grid to inject power during blackout situation. We managed to restart power supply to the western part quite soon, but the eastern part was a problem because we could not switch on lines that connect western part and eastern part because of voltage problems. The voltage was like 30% higher than it was allowed by the type of equipment that we use in transmission grid. So we had to solve a puzzle which elements in the east and in the west we had to switch off and on, so that we managed finally to switch on first line connecting east and west, and then in the morning we restarted the system completely. And after that we invented a procedure that prevented this from happening again. So I think we experienced like 20 plus massive attacks since then on our electric grid, and when we know that missiles are in the air, then we decrease the load on nuclear power plants in the west. We introduce load shedding schemes for the consumption in the east, and in that way we make the potential of these two parts of the power system even, so that even if they split us in two parts, these two parts are stable and do not collapse anymore. But that we invented only afterwards, after this blackout situation on 23rd of November 2022. We had quite bad deficit in 2022, 2023, and 2024. It's an average summer day. It's like a photograph of the power generation mix in the country. The red area, of course, is a deficit. And this is a cold winter day of 2024. We had to disconnect many customers during these 3 years, many times, during summer period of time and winter time. And we introduced rolling controlled power cuts in the country many, many times across all the Ukrainian regions because of quite big deficit of power. And we started protecting our facilities by using very simple structures like sandbags. They protect the most important electric equipment from, not from direct heat of a shahid or missile, but from debris and from shock wave. And in that way, we saved probably 50 or 60 auto-transformers in our system. Last year, we rolled out, first time in the world, we rolled out structures of this type. We call them level 2 protection structures. They stand direct heat of a shahid, kamikaze drone, or cruise missile sometimes. And we had to roll out 80 structures of this kind to protect the most precious and rare equipment in our power grid, which are auto-transformers. Every auto-transformer of this kind can power 100 to 1,000 to 1 million families. And of course, it takes a lot of time to manufacture those. And because, as I mentioned, we had 200 auto-transformers on a controlled territory, and we had to replace 185 in only 2.5 years, maybe. The question was in 2022, where we could quickly source auto-transformers, who has a stock? And guess what? Nobody in the world, of course, had a stock of this type of equipment. It turned out that order books were filled for 2-3 years ahead. And we had a lot of discussions with United States and Europe. I said, like, look, guys, you have probably 7,000-8,000 auto-transformers of this kind in your system. Even though the frequency standard is different, we know how to tackle with this. Can you give us the used ones? Not the new ones, but the used ones. You probably replace 400 to 500 a year. And I received an answer that, we are replacing auto-transformers only when they are completely out of operation. We do not do this in a planned way. So nobody had a stock. And we had to rely on Ukrainian manufacturer in the first place. We had to rely on our stock that we had before the full-scale invasion, because we did not scrap, we did not destroy the old machines that we just replaced with new ones before, and Turkish transformer plant that had very good logistics to Ukraine very quickly, logistic routes to Ukraine. So the question was how quickly they were able to destroy our system and how quickly we were able to restore. And the speed of destruction in 2022 decreased dramatically when first Patriot systems and other type of air defense systems were delivered to Ukraine. We were losing like 20 auto-transformers per attack in October. It went down to 2 to 3 in December of 2022. When we rolled out this type of structures, I think that Russians spent 1,500 missiles last year only targeting electric grid. We lost 10 auto-transformers. So We are installing them now much quicker than they are able to destroy. So now they started to bomb gas infrastructure. They do not bomb substations anymore, or they do it very rarely. But what they did, what they managed to do, is that they really destroyed half of our generation capabilities. And Ukrainian power system, as many other big power systems, was designed based on these economies of scale effect, that you need to have big power plants that evacuate power through big transmission lines, and then you just decrease voltage and distribute this power through distribution networks. Very good thing to have when you don't have war, but these 15 or 20 power plants in Ukraine that produce 95% of the output are perfect targets for Russian missiles. Perfect. If you can restore substations sometimes in 2 hours, sometimes in 2 days, sometimes in 2 months, to restore a power plant which experienced an attack of a 5 missile hit, you need like sometimes 2 years, sometimes 1 year, sometimes never. And we faced the problem that we were losing our traditional generation base from time to time. So with every attack, we were losing some units forever. Some units were not restorable anymore. Some units were cannibalized to restore other units. So we quickly realized that time is working against us in that sense, and we had to roll out new generation in Ukraine to compensate for the generation that we lost, the Soviet-style power plants. And we arrived at the concept of decentralized generation. So the idea is very simple. It's a military idea of decentralization of resources. Just as military people do not like to assemble 100 tanks in one spot, we also, instead of having like 1,000 megawatt power plant, we would prefer to have 110 megawatt power plants nicely distributed across the country. It is much easier to defend them. Russians do not know where they will be located because it's really hard to investigate all the locations of all these hundreds of power plants. And they can be quickly rolled out, especially if this is something, some balancing capacities like battery storages or even gas, maneuverable gas generation that can be containerized. You can roll out this in Ukraine in a matter of 5 to 6 months currently. And these projects are underway. And this concept of decentralized generation is something that is our response to this risks of military risk, actually. But also, even before the war, we as an operator of the power system did certain modeling how we could meet the demand in the future and how we could transform our power system, our generation mix, in a way that we would have cheaper, more affordable energy, but with using no coal and using no Soviet coal-fired power plants. And we arrived at certain calculations that mean that we had to phase out these thermal power plants that were heritage from Soviet Union and build new types of generation, the combination of technologies we would use to make system cheaper, but also to make it more resilient. And you know what? It turned out that Russians not only managed to speed up our interconnection with European network, they also effectively speeded up our transformation of power system, because the main target of their missile attacks in generation area were those big, inefficient power plants, mostly coal-fired, that were to be phased out anyway. And under this stress, we had to move quickly, and now we are rolling out a couple of gigawatts of new generation capacity. It's mostly containerized. It's battery storages, partially gas peakers, but also solar and wind farms that combined can deliver more resilient and stable power supply. And they are much less vulnerable to any missile and drone attacks. because we use technologies that cannot be destroyed by one missile or even by 10 missiles. So this is what we're doing now in Ukraine. We managed to protect our transmission grid. Our distribution networks were almost intact apart from the frontline regions. So the most important element now that we need to restore is generation. And by restoration of generation, we mean that we will not build big power plants anymore. We are switching to smaller ones that will be connected to a low and middle voltage grid, maybe 10 kilovolts, 35 kilovolts. And our transmission network will evolve to a state where it will not be transmission literally anymore, but rather will be interconnection network. So this network main function will be to keep the system integrated, and maybe it will transmit less power from one region to another, as you will have these sources of power near the sources of demand. I conclude my first introductory speech here. And I think we meant it to be like more Q&A session. And I will be happy to tell you about other different aspects of energy resilience that we invented for ourselves, including cybersecurity and staffing issues, whatever you would be willing to ask. Thank you very much.
Yeah, this is really quite remarkable, and here's a hooray to the forced decarbonization and energy transition of Ukraine, and the unintended consequences.
Unintended decarbonization.
Unintended decarbonization. But thank you. This was a remarkable tour de force through the ordeal that Ukraine has been through, and also the remarkable resilience, really, of the grid and inventiveness of and hard work of the people who managed it. I will be happy to collect some of the questions, and as you make up your mind, please raise your hand. I will take a note and call upon you. There's a microphone. And while you do that, let me just start with a question. You mentioned it about cyber, right? A lot of us in the field were thinking critical cyber attacks against critical infrastructure. You know, this is going to be the main challenge. Turns out old school kinetic action against critical infrastructure is not out of the picture. But can you speak to this cyber dimension of what you had encountered?
Since 2016, when we experienced first serious cyber attacks in Ukraine, one hacker group managed to get the control over circuit breaker on the high voltage substation near Kyiv. They shut down customers for a few hours. That indicated a major vulnerability, not only to us, but also I know that this case was well known here in the United States. It was also analyzed here by certain laboratories and institutions. And since then, we invested as a grid operator, we invested more than $100 million into cybersecurity. We created industrial security operations center for the cybersecurity. We used white hackers to probe our perimeter all the time to search for vulnerabilities, but also we bought a lot of expensive stuff to create uninterruptible and quite dense perimeter. And when and also we separated obviously OT from IT. This is no brainer. And also we started to operate our own telecommunication network through which we transmitted data from control centers to substations and other objects, and also to power plants. By the way, it was a recommendation, very firm recommendation of United States. I think it was Argonne Lab at the time. So we managed to build our own telecom network. We were one of the biggest telecom operators in the country when we finished. And we obviously separate physically our technological network from internet. And when invasion started, the amount of cyber attacks increased by 10 times immediately. And I can assure you, Russians would never spend their strategic missile resource on electric grid elements if they were able to shut us down through cyber attacks. So it's absolutely evident to me that they started penetrating the system. They tried to do it for 5 to 6 months, and when they realized they could not bridge the perimeter, they started this missile campaign, physical destruction of the grid. Because otherwise they would be able to shut us down just without spending tens of billions of dollars and spending strategic resources as ballistic and cruise missiles, which they can produce only like 40 to 50 a month. And they already spend more than 2,000 only on electric grid. So basically they will not be able to replenish this stock in maybe next 5-7 years. So this cybersecurity element was absolutely critical for us to survive. And when we connected to European power network, their biggest reservation was that we would decrease their cybersecurity level. But when we compared the instruments that we used and their cybersecurity instruments, turned out that we were donors of cybersecurity, not the recipients of it. So there was no single event of a perimeter breach since 24th of February 2022 into Ukrenergo network, the transmission network.
Thank you so much. I saw a question here. Could we please, and then maybe we'll collect a couple right away on.
Thank you so much for. I'm Joel Brenner from MIT Center for International Studies, formerly in U.S. intelligence, and spent some good part of my career in critical infrastructure protection. And you've addressed some parts of my question, but I wonder if you'd go a little deeper into the mechanisms that you use to protect the system. You mentioned perimeter protection, which is in many cases not so effective. And you mentioned isolation. Would you be more clear about what you isolated and how?
Well, sorry, I'm not sure that I understood you correctly, but if we talk about physical protection, if you're interested primarily in physical, not cyber protection, then we had to protect the most vulnerable parts of the substation, which is transformer equipment. Because circuit breakers, disconnectors, all the switch yards, because we used open air switch yards, they're large. They occupy big territory. And even when missile hit it, you are able to restore power supply to customers in a matter of hours, maybe days. But if you lose the auto transformer, you may be in trouble for 1 month, 2 months. So what we did, first of all, we called to 400 firms manufacturing and using auto transformers of this type around the world. We managed to find 3 existing auto transformers in the world that we could quickly bring to Ukraine and replace. But then we placed orders. And 2022, we survived using the existing stock and cannibalization of our own substations, because Ukraine's grid is much stronger than Ukraine's current consumption level. So the grid has overcapacity. So we managed to, for some time, we managed to survive by simply cannibalizing those substations which were unaffected, by moving transformers from one substation to another. And then we protected them using this, as I mentioned, level 2 protection. And the design was invented by us and by our general staff. So we worked quite closely with Americans as well on the design, but your institutions, they proposed modular structure. So basically, they proposed to us that we would assemble these shelters, not from the concrete and rebars, but from some, Lego-like structures. And the problem was that such a structure could easily collapse, especially if the missile hit is nearby. So we used these structures, 3 levels of rebars, 1 meter of concrete, of refined concrete, and 300,000 tons of concrete per each shelter. The height of this shelter is 25 meters. So it's a big structure that protects the most critical type of equipment. And as soon as you can protect your auto transformers, you're almost there in terms of protecting your transmission network. Because if you have open air switch yards, they are almost impossible to destroy completely, even by 3-5 missiles. So you need to protect auto transformers. Another thing that we stopped doing is to build this compact gas insulated switch yards, because such a switch yard can be destroyed by one kamikaze drone and you will not be able to recover in 1 year. So good old traditional format of a switch yard is essential to survive, for your transmission and distribution network to survive, because otherwise you're in trouble. So this is about physical protection. And of course, we had to communicate a lot with military forces to tell them which targets might be more or less vulnerable. But this is the part where I'm afraid I cannot share a lot of intel with you today. But of course, I had to have many new friends in military structures of Ukraine, but also United States.
So gentle.
Oh, my name's Andrew Kudrytskyi. I'm with the MIT Climate Collab of the Center for Collective Intelligence. Thank you very much for an informative presentation. The strategy of decentralizing sources of generation is, needless to say, very promising, and it's being promoted by the EU's Ukraine facility platform, as you know. It's unfortunately stalled at that level. It's making very modest progress. So perhaps you could comment on that very bottleneck that it seems to exist. Secondly, you would know that there are municipal centers in Ukraine that are currently operating autonomously of the grid, those being Zhytomyr, Khmelnytsky, and Vinnytsia. Okay? Under their strategy, are they accomplishing the purpose of decentralization from the grid to some significant extent? And if that is the case, why couldn't their strategy be adopted by other municipalities in Ukraine? Thank you.
Very nice question. First of all, what I learned from this 3 years of full-scale war, international aid and international financial instruments work very well when we talk about emergency support. Like, we need to buy 100 auto transformers. We can source money from some credit agencies or donors, and we can effectively place orders and buy those. But these instruments are much less efficient when we talk about systemic processes that have to be motivated by economic incentives. So when we talk about decentralization of generation, making grid more green and this kind of stuff, we have to create economic incentives, and we need to rely on private capital mostly, because state cannot do this job, cannot transform the power network. The state can only help to restore some, to eliminate some emergency, but not transform the grid completely. In Ukraine currently, we do this decentralized generation rollout not only because it's safer, but also because it's cheaper. If you compare the economic parameters of operation of a big gas-fired power plant and a containerized gas piston 10 megawatt installation, you would see that the running costs are almost the same. But the time that you need to roll it out, the smaller one, the human effort that you need to service the smaller station is incomparably small if we talk about big 1,000 megawatt type power plants. And therefore, there is an economic incentive to build those small power plants all across the country. And current economic payback of such projects could be 2-3 years. So it's really, the prices are quite high because of deficit. I demonstrated it to you just on the graph. So the paybacks are very short. And people do this because they like to invest into this energy objects. They like high IRRs and high NPVs, not simply because they like the idea of decarbonization as such. But of course, the good thing is that these economic incentives, they luckily for us coincide or are similar, drive the things in similar direction that the effort to decarbonize. And the second about those cities that you mentioned. First of all, I would not overestimate the degree of autonomous status that they achieved. They currently cannot cover full volume of demand by using only local sources. But what my personal view is that the proper way to develop the electric grid of the future would be to create a certain fabric or certain network at the level of 10, 35, 110 kilowatts, whereby you would have connected customers and generators, and you would reinforce this fabric with strong transmission grid that would keep this fabric integrated across the country, instead of going into islands. Because when you go into islands, when you want your like Boston, for example, or Cambridge to be completely autonomous in terms of power, at least it would be costly, but it also may have certain safety, energy security implications. Because when you have this fabric, and you have outage of several elements which are critical for the town, you will source power from another region, right? When you have this pure islanding concept, you will probably have problems sourcing power from elsewhere. So it's much better to use this network principle when you design the electric system of the future. So instead of having large power plants, you have hundreds of smaller ones, but you do not completely disconnect one area from another. You need to keep them integrated at all times so that the grid is more resilient. This is something which is important. So it's not that important to me if Zhytomyr or Boston can really cover its demand using generation which is physically localized here. I would say it's important that Boston has power supply from so many sources that it is almost unbelievable that all of them would be taken down in one time. This is probably more important thing to have. So I think that Ukrainian cities will go that way. So, and Ukrainian power network is already going that way. So we're decentralizing it, but we are keeping this fabric of the power system integrated.
So let me just pile on to that. So in that case, your grid is not really sort of divided into transmission and distribution, but
Yeah.
perhaps something in between.
Yes, and it's like you don't have a local. You cannot switch off internet by turning down few servers, right? And you cannot say that this particular server is servicing this geographical internet area. So you create you to a certain extent you have to virtualize your electric grid, and you do not care that much where this power plant is situated. It should be close enough so that it would deliver power to the customer, but also you need to have so many sources of power around you that you will not know which one is more or less important, so to say.
Could you please introduce yourself?
Thank you. Volodymyr Kudrytskyi, research fellow at GMF program here at MIT, but also I'm a associate professor at Kyiv Polytechnic Institute in Ukraine. Since I'm a cybersecurity professional, I will get back to cybersecurity question. So we all know that critical infrastructure is the first and primary target for in any kind of wars, including this kind of hybrid war. And we all know that in 2016, or even way before, we have already seen the attempts of Russians to shut down the entire system, specifically Prikarpattia Volodymyr case, and there were some other cases, smaller ones. So I will have two questions. First is, do you, according to what you know, because basically you're
What
not
I can say.
What I can say, of course, as well, right? I mean, to your knowledge, do attacks become more sophisticated? Do they still keep attacking the entire system since they have already launched conventional attacks on power grids? And my second question would be, because cyber field does not recognize borders, and we are always on the front line. Even here, we're on the front line of this larger war, if I may say. Do you have, obviously you do have lessons learned, but do you have any connections with respective institutions here in the United States or maybe other allied countries? Do you talk to them? Do you share the information? Can they learn from what we unfortunately have experienced? Thank you.
Yes. We do have strong connections with US institutions on this matter, obviously, and we shared a lot of data. Before the invasion, it looked like they were teaching us how to build up cybersecurity systems. After the war, the full-scale invasion started. It's not that clear anymore. It's not that obvious anymore. With regard to your first question. Lessons learned. Well, obviously, you cannot let yourself, you cannot let your critical networks to touch internet at any point, which is probably obvious. But it's also important to track the supply chain for your equipment. What we did, we actually monitored the equipment logistics from manufacturing place to the site, because this is where you can get certain unpleasant surprises on the way to your site from some distant locations. Without calling, of course, names, but some countries that produce a lot of electric equipment, they sometimes may even leave hold certain control over your electric installation appliances after they sell you the equipment. And this is something that I heard a few stories just lately about battery storage systems, and which were somehow operated from another country just for the kind of maintenance purposes or something like that. So you need to make sure that the equipment is clean, and you physically separate OT from anything else. And it's much better than you don't use external telecom network as a primary net data transmission system. You may use last mile, which can be rented from external sources as a backup, but you primarily need to have your own network if you are a critical infrastructure operator. It's costly, but you are under you gain control over much more things.
Hello, I'm Dana with EECS. So far you've talked mostly about warfare or Russia fighting in terms of cyber warfare and physical warfare. But there's another way which I would think they could, or at least I know to some degree they've been fighting, which is that you mentioned that there's a lot of legacy thermal power generation from the Soviet era. And I know a lot of the nuclear powers from the Soviet era. So all the parts from I've read that a lot of the parts from that and other stuff needs to be imported from Russia. In fact, I remember reading something about there being issues with even getting processed nuclear fuel, that Westinghouse could solve that, but just because of a specific power plant built in Finland in the 70s. So how much of an impact is this limitation on Russian hardware for maintenance been, and how have you overcome that?
Thank you for this question. I think at the present moment, this dependence on Russian spare parts is quickly approaching to zero. We do not use any Russian spare parts for substations, obviously, and thermal and hydro power plants. For the nuclear power plants, we produce the big number of spare parts in Ukraine, and we have Westinghouse fuel at all nuclear power plants that are in operation, and at one power plant that is not under control of Ukraine, which is Zaporizhia. So we do not source nuclear fuel anymore from Russia, and also we've just finished the new nuclear fuel storage in Chernobyl area, which we use to substitute this Russian storage that we used for many, I would say, decades. And we paid a lot of hundreds of millions of dollars to Russia for storing this fuel in Russia. So we don't do this anymore. So I would say that we managed to quickly compensate or eliminate this dependence on Russian spare parts and Russian technologies in Ukrainian system. And of course, all solar power plants, wind farms, battery storage systems, gas pistons, all new installations and equipment for the substations have nothing to do with any Russian components or technologies.
Let me, okay, I'll take a question right here. And Elizabeth, do you have questions online? Okay, all right, go ahead.
Arek Danagulian, Nuclear Science and Engineering. So could you say that Ukraine has essentially doubly benefited from nuclear power because it gives it power independence, energy independence, and it appears that while Russians are able to destroy, gas-fired plants, coal-fired plants, they do not touch nuclear power plants?
Well, I cannot say that they did not touch nuclear power plants because they actually attacked Zaporizhia when they were seizing it. They obviously captured Chernobyl nuclear power plant for 1 month. They were occupying it. but not less importantly, they always try to attack adjacent substations that evacuate power from nuclear power plants. What they're trying to do, because those nuclear power plants in the grid, they're like, dumbbells that are hanging on the very thin rope. They try to cut them off the grid to the extent possible to create disturbance that would in turn create cascading effect in the grid. And they did it many times. They tried to do this many times. So while nuclear power provides really stable power supply to the system, it's not sufficient. On one hand, it's not sufficient to even cover demand of industry and critical infrastructure. But on the other hand, when you have this concentrated source of power in one spot, you expose yourself to other types of risk, stability issues in the grid. So if you ask me whether this decentralized network would do better than a network where you have like 55% of the power coming from 3 power plants, I would certainly vote for decentralization. And this is putting even aside economic value or cost of new nuclear power units that inevitably is very high, as you know. So we are able to use this Soviet legacy to survive, but this is not the way forward, I would put it this way. This is not something that we will have to rely on in the future 2 or 3 decades.
There was a question all the way back there. Traveling there, can I just do a follow-up on the supply chains? So so sort of not having independence of Russian supply chains, but can you speak to the supply chains for say, transformer manufacturing? This seems to be a really critical piece of equipment.
Oh, yes.
Who makes those now anymore?
China, India, Turkey, Ukraine. And I was quite surprised that I think that US companies, to a very large extent, moved out production facilities to other destinations as well. So I think Western world and Western countries rely too much on a very small number of large suppliers of these critical types of equipment. And it's not only about auto transformers, it's all the types of electric equipment. And this type of dependence is really, really dangerous, as we learned it from our own experience. And we were lucky that one big transformer plant was located and was still operational in Ukraine. This industrial factory actually had its best times ever since 2022 till 2024. They manufactured more products than during Soviet times, I think. But this is, of course, not a good thing for the country, but it just illustrates how important it is to have something within your controlled perimeter, especially if the big war happens. And God knows what politicians in these different countries will decide tomorrow.
Hi, my name is David Su. I teach urban studies and planning here at MIT. I also work with the U.S. Department of Energy, and I study electrical grid. And so I'm kind of curious, one thing you mentioned about consumption, the electric grid for 150 years, we always try to supply energy whenever people want it in normal conditions. In a wartime situation, I'm really curious if consumption habits and communication has changed. It's all critical infrastructure, but not all uses are critical. And so I'm wondering if some uses are classified as more critical than others, or there's non-critical loads that people are willing to change their behavior in this more urgent wartime situation, and how you communicate with your users, customers, citizens about what critical and non-critical loads might be.
Yeah, thank you very much. Well, of course, we have mobile application that informs population about deficit or surplus of power, but in 2022, it's really interesting because it's like part of probably behavioral economics. When these shellings happened first time, I went to the national television and said, like, look, we need to save energy. We'll be having trouble this winter, and we need to, you know, quit using large electric appliances during evening peak hour or something like that. And for a few days, people changed their habits, and there was a drop of consumption by 6 to 7%, which for such inertial system as electric grid is a large change. However, people adapted to this pressing circumstances, and they just quit reacting on the public communication. So, frankly, the application of load shedding scheme is not that easy as it may seem, because you always have critical infrastructural elements that you cannot switch off the grid, right? And then you have certain residential buildings which you cannot switch off as well because they're powered by the same power line. And then you have a neighbor problem. And look, in Ukraine, it was a major problem because, like, I had like many discussions with president about the even distribution of electricity among population, because everybody was pissed off, not because the power was out, but because the neighbor wasn't switched off because the hospital or heating station was located nearby. And this creates such a strong social tension, especially when these power cuts are really bad and you are without power during winter time, like for 7 hours, and you cannot go take a shower, you cannot, prepare something, cook something for your kid, or so you're limited in your normal life. Russians use this to inject some parts of the propaganda and to use the situation to even amplify this tension. For example, they created this narrative that in reality, we were selling power to Europe to keep Ukrainians without lights, you know. And they demonstrated data from ENTSO-E website. ENTSO-E is the electric network of Europe, where they demonstrated technical flows. So they said, like, and there are some loop flows, like from Romania to Ukraine, from Ukraine back to Romania, because Romania has weak grid. They are pushing power from south to north through Ukrainian grid. So they just looked at Ukraine-Romania border, where you had the power flow of, let's say, 400 megawatts. And they injected these messages into the media that we were exporting power during customer disconnection time. So it created such a big political tension within the country that it really affected power system operation to a certain extent. And that even distribution of electricity among population, when you have some manual operations to be done by distribution network personnel, when you have this critical infrastructure objects which are on the same power line with non-critical objects, and you have millions of elements in the grid, it's really hard to tackle this task. And I can tell you, after 3 years, we still do not have ideal system. And if, God forbid, some other countries would face these challenges that they would need to disconnect customers, it's never perfect and never will be.
Why don't we collect two of them?
My name is Robert Stoner. I'm the former director of the MIT Electric Power Systems Center and the interim director of MITI. And I was thinking as you were talking, this is probably the luckiest man in the entire global electrical industry. I mean, here he is just at the very end of this very elaborate program to interconnect the European system. You know your system technically as well as anybody knows it, probably better. You've been thinking about cyber a lot. You've got excess generation capacity. You've got nukes that are maybe hard to hit or undesirable to hit. There's quite a lot of resiliency there, and you're just about there, which made it easier for you to do some of the things you did than otherwise might have been the case. But on the other hand, I began to think, well, maybe it's the unluckiest man in the electric power industry, because surely this was apparent to the Russians. And I began to wonder, to what degree was your readiness to interconnect with Europe an influence on Putin's decision about timing of the invasion?
Well, that's a question I will probably never know the answer for sure. But the fact that Russians picked up the date of disconnection, probably they knew something. Probably their dispatchers were instructed to pick up this date from above somewhere. But you know what? We were fighting with Russia since 2014 on the gas issues. Nord Stream 1, Nord Stream 2. We were fighting here in the Congress to cut this pipe from Russia to Europe, to Germany. And Stockholm legal case, I was in the supervisory board of Naftogaz, this oil and gas company at that time, and I know this very well. So it was all in the press, all in the media at the time. This energy power system interconnection project, we kept it under the radar until 2021, until we were so ready that even Europeans could not really challenge this fact. And actually, they made studies, steady state and dynamic studies on the Ukrainian grid power system possibility to be connected to Europe. And these studies have demonstrated that we were ready at the time. We have to build like hundreds of kilometers of power lines, new substations. We had to refurbish every single generator controller in every single big power plant to control voltage and power in a manner that would, let's say, be acceptable for Europeans. And God knows they applied highest standards to us. I mean, they made no excuses at that time. And when those studies in 2021, they were released, they have shown that we were ready to connect to Europe. There was no, and we were promised always that it would be a purely technical exercise to do these studies, and the conclusion would be purely technical, because at that time when they started it, they believed that it would not be technically possible. So they said to us and to me that, like, Volodymyr, it will be technical. Don't worry, it's not political. It's just a technical exercise. If you're eligible, you will be connected. If not, you won't. So when they did studies, and some, I think some operators in Europe, they were terrified because the whole strategy collapsed. And Russians, they were convinced that we would not pass the test, that we would not be eligible, compatible with European system. And when these studies were released, I think it was too late for them to somehow prevent this from happening, because politically it would look awful for Europeans to say, you know, Russians are against it. Their soldiers are on the border, so we probably we promised you that it would be technical, but now it's political. You know, it's not something that politicians like to do, to admit to those things. And finally, it turned out that they helped us to interconnect even faster than we expected. And I think that it is our reaction that determines if we use this crisis for good or if we just, you know, collapse.
Yeah. Christoph Schmidt, doing research on power systems at LITS here at MIT. And I was wondering, you talked a lot about decentralization of production capacity. How could you talk about also about the digital orchestration of all of these decentralized assets? Because I think where I'm from, a lot of gigawatt of capacity of decentralized generation still waits actually to be connected to the grid, and kind of operators do not really make progress of like integrating all of that capacity into the existing grid. And maybe what can our nations learn from Ukraine on that topic? Yeah.
Well, frankly, I don't see any particular technical problem or showstopper problem that would prevent us from dispatching those, like even hundreds of those installations across the country. I can give you one good example. In 2022, we introduced the system for renewable curtailments. So our dispatcher uses this system to enter the number of megawatts it needs to curtail in a particular moment. And the system automatically sends the dispatching order to hundreds of solar and wind farms across Ukraine, all of them which are larger than 1 megawatt of installed capacity. And these power plants are automatically disconnected, or their generation is decreased. And then the system automatically calculates compensation. So I don't know if this is a problem here, but for Ukraine, this decentralized generation and dispatchability of this decentralized generation is not an issue. It could be an issue for demand side management, when you would manage, instead of managing like hundreds and thousands of small power plants, you would manage millions of electric appliances that consume power. For example, we had a project, we call it Namion, to control boilers in the apartments of millions of Ukrainians. And here you would need probably much more sophisticated software, but also aggregation and different kind of cybersecurity protection. But if we talk about purely decentralized generation, I don't think that it would be a technical challenge, frankly.
Is there a role for AI in managing this kind of system?
Well, yes, because AI can be trained to, first of all, we use AI to make recommendations. We're not brave enough yet to let AI actually manage the system. But as this recommendation will be more and more precise with time, I think there will be a substantial part of the simple dispatching orders that can be outsourced to AI at some point in time.
Hi, I'm Barry Posen. I teach in the political science department, and I'm in the security studies program. Your talk was really great and provided a lot of insight into a lot of things. I'm going to ask you to stand back from it for a second, because as I listen to the talk, I'm sort of thinking you and your military counterparts in the Ukrainian military and intelligence, you're playing in a strategic competition, a campaign. You're playing a defensive campaign against another collection of individuals' offensive campaign. And through your talk a couple of times, you said, well, they expended this many munitions and this is all they got, or they expended this many munitions and this is what they got, or then they changed from one target set to the other target set. I guess what I'm going to ask you is a couple of interrelated questions, which is, do you think their overall objectives changed over time? Right? They were always attacking the grid, but where they were attacking the grid to achieve some other thing. What was the other thing they were trying to achieve? And second, how do you evaluate them? I mean, you've told a story here of high level of adaptation, and responsiveness, innovation. How do you view the other side? Kind of stolid and stubborn, adaptive in their own right, mysterious maybe after competing with them all this time? So, I mean, you see the thrust of my question. Answer it any way you want.
I think they are also highly adaptive. And this is something that I know from those guys that are fighting them on the front line as well. My younger brother is in military service, so I know a lot of things, obviously, from that end. Their weakness is that because they have this autocratic style of management, sometimes it's good because it has high ability to concentrate effort. For example, they can send people to this endless attacks, and they can lose like 1,000 people a day, and they can continue to do this tomorrow and the day after tomorrow. And so this is a strong side. The weak side is, however, that in such system, you are reluctant to tell bad news to your superior, and your information flows from bottom-up information flows. They lead to the situation when generals do not quite understand that their current tactics is not successful. And there is a time until Russians realize that they do something which bring no result. For example, they continued wasting their missiles at our substations, even in 2024, I presume because one general promised to Putin that, Mr. President, we're so close to breaking them down, believe me, it takes one or two other attacks and we'll be there, you know. And because this system punishes bad news, so he couldn't tell the truth that this tactics was inefficient and they needed to switch to another tactics. They probably wasted more resources on inefficient attacks than they might have. This is my observation. So yes, it's a strategic game in electric field. The nature of the game is who will be faster. They trying to destroy the grid, or we trying to recover. But the main target, I think, they did not change. The main strategic target they tried to achieve, and they're still trying to achieve it, is to break something in non-military critical systems that would lead to collapse of the front line eventually through a certain mechanism. Like I said, if they managed to initiate full blackout during winter time, the water supply and heating systems would be frozen, and that would lead to humanitarian catastrophe, and that would lead to inability of the soldiers to fight in the end of the day. So I think that they did not change this strategic target, but they simply do not know how to achieve it tactically. Yes.
We're at the end of our time, unfortunately, although of course not at the end of the interest in the topic. Please join me in a warm thank you to Mr. Kudrytskyi.
Thank you very much. Thank you.